Hello and welcome to our presentation of the Automated Smart Irrigation and Environmental Control System. This system integrates various components like sensors, motors, and controllers to automate plant care by regulating water, temperature, sunlight, and food. Each of us will explain our specific part of the code, how it functions, and how it contributes to the overall system.
Hi, I'm Harisa and I'm responsible for the rain detection and fail safe system. Let me walk you through the code and how it helps in rain management. The rain detection part begins by reading the rain sensor value. In the setup function, we declare the pin for the rain sensor, pin mode, rain sensor input. Then in the loop function, we continuously check the rain sensor by reading its analog value using analog read. This value tells us whether it's raining. If the value exceeds 150, it indicates the rain is present and will trigger the rain system. Next, in the rain system function, we check if the motor is already running using the motor1 variable. If the sunroof is not already closed, motor1 equals to fail. We stop any ongoing sunroof movement and close it by stopping the motor. Otherwise, if the sunroof is open, we activate the motor to close it and wait for a few seconds. This ensures that when rain is detected, the sunroof roof closes automatically to protect the system from water damage. Now let me show you how this works in thinkerCAD by stimulating rainfall. As you can see, the sunroof are opening using the equator motor for 50 seconds. When the rain sensor is very high, the motor will spin in the other direction to close the sunroof.
Hi, I'm Brian, and I work on the plant watering and ventilation systems. These systems are essential for maintaining optimal conditions for plant growth by ensuring proper soil moisture and temperature control. Let's go over how they work. Firstly, we declare variables for each of the sensor, and then we declare the pin mode for each of the sensor, and then we read its analog value. For the plant watering system, the plant watering system uses a soil moisture sensor to determine if the soil is too dry or too wet. In this code, the sensor reads an analog value which helps us decide the necessary action. If the soil moisture is below 300, meaning the soil is too dry, the pump is activated to add water. Conversely, if the value exceeds 600, indicating the soil is too wet, the pump removes excess water. If the value falls between 300 and 600, the pump remains inactive to conserve resources. This system keeps the soil within the ideal moisture range to support healthy plant growth. For the ventilation system, now let's talk about the ventilation system. The system uses a temperature sensor to monitor the environment. If the temperature exceeds a threshold of 200, the ventilation motor activates, opening the vents to cool the space. When the temperature returns to a normal range, the motor stops, conserving energy. This ensures that the plants are not stressed by excessive heat, maintaining an optimal environment for their development. By this, we will ensure the plant stays in a very optimum condition.
Hi, I'm Hazim. I work on the sunlight control feature which adjusts the sunroof based on the light level detected by the sensor. Let me walk you through the code. First, I would declare the first motor 1, which will tell us if the motor have been on and off depending on if it's true or false. Next, the light sensor variable I declare it, and and the sunroof manual switch. First, the void setup. I declare the pin for the motor, which is pin 5 and pin 6 as an output, and declare the manual switch for pin 4 as an input, and the light sensor in pin, I think it's A1, yeah, pin A1. Next, the sunlight function. First, we have to check the analog analog read light sensor, we have to read the light value, and then output the light value in the terminal. Next, we have to check if the light is too low or too high. If the light is too low, below 100, and if the motor is false, like it haven't closed yet, it haven't opened yet, we will open the sunroof for about 50 seconds, which is about 50 rotation at 200 rpm, and then after 50 seconds it will stop for 2 seconds, and the motor 1 is equal to true, so because it's already open, so it's true. Next, if the motor is true and the light value is greater than 180, so the light is very intense, we will close the sunroof for another 50 seconds on the other direction, so it will be negative 200 rpm, which is 50 rotational the other direction. And then after 50 seconds it will close it will stop the motor and delay for 2 seconds, and the motor 1 will be false. If anything else, if the light value is between 100 and 180, the temperature would be perfect for the greenhouse, so the motor will not do anything for 2 seconds, and this will and this function will be called upon at a void loop when void loop. Okay, this manual switch, if the manual switch is false, we call upon the sunlight, right? We call the sunlight function. And if it's true, if the sunroof manual is true and the motor is false, we can open the sunroof for 15 seconds. It's the same code as before, and then make motor 1 as true. This is only for opening the sunroof manually, and that's it.
Hi, I'm Danya, and I'll explain the chicken feeding system. The system uses an ultrasonic sensor to determine if the food container needs refilling. Let's break down the code and its functionality. In the code, we first define the pins for the ultrasonic sensor and read the distance using read ultrasonic distance. This function measures the time it takes for a sound wave to bounce back from an object. Based on this, we calculate the distance. We then use the calculated distance to determine if more food is needed. If the distance is greater than 180 centimeters, it means the food level is low. So we activate the food dispenser motor to add more food. If the food level is adequate, the dispenser remains inactive. The motor will run to dispense food if the distance is too high, indicating that the food is low. This ensures that the chickens always have enough food. That's it for our demonstration of the automated smart irrigation and environmental control system. We've shown how sensors and motors interact with each other to automate the care of plants, optimize light, and ensure proper irrigation and feeding. Thank you for watching, and we hope you found our project informative.